Hello to everyone, I am Lorenzo Piccinali, and together with Aidan Hogg and Filippo Fazzi, we are the coordinators of the Spatial Acoustics and Immersive Audio Special Interest Group. So let's go straight to look at the future research challenges we are proposing here. The first one is related to the seamless blend of virtual and real sources in both virtual reality and augmented reality. Let's consider this scenario. We are on the natural and the real life. We hear sound sources around us. And in this second scenario, we can actually blend real sound sources with virtual one. And when we do something like this, we need obviously to create perceptually convincing and plausible virtual sources. Now, this challenging has got several steps to be tackled. The first one obviously related to the realism and plausibility of the rendering, whether it's headphone based or loudspeaker based. We need to render sources that sound as if they are there in that position and they sound real. Then we need to deal with the acoustic matching, for example, between the real and virtual environments if we are in a situation like an augmented reality one. So we need to match the virtual environment with the real one, therefore gather information from the real environment, simulate it and model it and render it in real time. And we also need to consider the listener's acoustic personalization, for example, their head-related transfer function and other features of every individual listener that needs to be customized in order to obtain the right level of plausibility. So this is a big challenge with several points, but an important one. The second challenge is related with the use of AI, of advanced statistical methods in immersive audio. And a good example is the matching between HRTF and individual, or maybe the synthesis of an HRTF. And this is where we can use active inference or advanced statistical methods and machine learning to find the best fitting HRTF for every individual, starting from a small or as a large number of parameters on the individual. And this can also help us moving forward and advancing in another important area, which is spatial hearing perceptual models. So if we can model the behavior, sensory and perceptual behavior of listeners, then we can improve, of course, the way we render sound specifically for the individual. And there have been a lot of interesting advances here, which can be and will be informed by data-based approaches such as machine learning and artificial intelligence. And finally, the third area is less research-based, but more based on applications. So where do we apply this technology, these immersive audio technologies? And an example is in audiology and audiometry. And in this case, includes also a validation with more traditional methods. So here is an example of a project we are doing here at Imperial, where we're looking at EEG, so some sort of psychophysiological, electrophysiological measurement in order to gather information about the type of rendering we're doing, the source position. We can do this with loudspeakers here on the left and with binaural and headphones here on the right. And the idea is to use more and more these immersive audio methods to validate and to maybe take the place of older audiology and audiometry evaluations. I think that is it from my side, and good luck with your work.